Hi, today we'll learn about Laplace transform and the theorems of Laplace transform and inverse Laplace transform. So Laplace transform. In mathematics, the Laplace transform is an integral transform that converts a function of a real variable to a function of a complex variable. The transform has many applications in science and engineering because it's a tool for solving differential equations. In particular, it transforms differential equations into algebraic equations and convolution into multiplication. Now, we'll learn about the theorems of Laplace transform. We will learn some theorems of Laplace transform that are first translation theorem, second translation theorem, derivative theorem, integral theorem. So now we first look up to the first translation theorem. So in first translation theorem, we can see here if E of AT is multiplied by FT, and we will do the Laplace transform of this AT or into F of t, we can get after Laplace transform these functions. Capital F of S minus A. And it can be written as integration of 0 to infinity limit e to the power minus s minus a into t f of t dt. Okay, now the second translation theorem is like this. We can go through the derivative theorem. If after derivative, when we do the Laplace transform of dtt of ft, we can get s of f of s minus f of 0 plus. This is f of 0 plus, it is the initial condition. And in the integral theorem, if we do the Laplace transform of integration of f of tau d tau, and the limit is 0 to t, we can get 1 by s f of s. And the inverse Laplace transform. The inverse Laplace transform actually is the inverse of Laplace transform. An integral formula for the inverse Laplace transform called the Malin's inverse formula, the Bromwich integral or the Fourier-Mellin integral is given by the line integral. So we can get the f of t, we can recover the f of t from the inverse Laplace transform, and this is the formula here. So we have learned about the Laplace transform, inverse Laplace transform, and the theorems of Laplace